So in this video, we're going to go over converting exponential equations to logarithms and logarithms to exponential equations. So whereas subtraction undoes addition and division undoes multiplication, a logarithm undoes raising a base b here. This is base b. When we move it over to a logarithm, it is the base of the logarithm, and that's what that lower b is. And then the exponent goes on the other side of the equal sign. Notice where the exponent goes. And then the a is what we're taking the log base of, okay? So b cannot equal, b has to be greater than 0, obviously, because we're not going to do a negative number there as a base. Also is not going to equal 1. So example 1 is converting from an exponential to a logarithm. So we can write exponential equations as logs, logarithmic equations and vice versa. So reading the math, we read log base b of a is x. So that down here, this b right here is our base. So it's log base b of a is x. Notice that the log is the exponent. So the base of the exponent becomes the base of the log. The exponent is what the log is equal to, okay? So when we write the exponential equation in logarithmic form, when we do these, again, we're going to take our base here, and it's going to become our base there. Then we're going to take what the exponent was right here, we're going to put it on the other side of the equal sign, and then the number we're taking the base of is going to be the 243, okay? So let's see if you guys can try it. Okay, once again, base, base. We're going to take whatever was the exponent right here. We're going to put it on the other side of the equal sign. And then we're going to put the 125 right there. So that's 5 to the third is 125, right? So log base 5 of 125 is 3. Here we go again with our example 2. Now, the only difference this time is we have a fraction, right? So here again, we're going to take our 25. That's going to be our base, right? We're going to take that 1/2. And we're going to put it on the other side of the equal sign. And then we're going to put our 5 right here. So it's going to be log base 25 of 5 equals 1/2. So go ahead and do the U try. Here we go. Again, 27 is our base, right? Then we're going to take our exponent 1/3. And 27 to the 1/3 power is actually 3. So, and then we're going to take this 3 and we're going to put it right here. Okay? All right, so an exponent or log can be negative. So we can say, again, we're going to keep on the chain that we were on. So we're going to say log base 4, right, of -2 is going to be equal to 1/16, okay? So again, if we take 4 to the -2, that's 4 squared, and it's going to go to the denominator because it's negative. So that's why it's 1/16. So you go ahead and do the U try. Here we go again. Here's our base, log base 6 of, and we could just take what's on the other side of the equal sign and put it next if we wanted to. Of 1/6 is what? Our -1, right? So log base 6 of 1/6 is -1 again, because 6 to the -1, we would move the 6 to the denominator. So it would be 1/6, okay? So remember, when you take any base to the power of 0, it is equal to 1, right? So what we're going to do here, same thing we've been doing. So again, we've got our x down here, log base x of what? Yes, our 1 is going to be equal to our 0, okay? Again, the next one, go ahead and do it. Come back to me when you're done. So here we go again, log base 6 of 1 is going to be equal to 0 as well. So 6 to the 0 is 1. All right, so our next two, the log and exponent, can be variables, right? So again, we're going to take a log base a of what? Our c, and that's going to be equal to our b. Go ahead and do the next one. So we're going to do again log base r of our t over here is going to be equal to what? Our s. So r to the s is equal to t, so log base r of t is equal to s. All right, so go ahead and work on these and come back to me when you're done. Oh no, sorry, not these. We're going to actually now go from log to exponent. So remember, our base is our base. So here's our base, 9, and we're going to take it to the power over here, the 1, and 9 to the first is what? You got it. It's just 9. Okay? So here again, you try. So the base of the log becomes the base of the exponent. The log is what the exponent's equal to, right? So here we go again. Take our base, the 5, to the what power? You got it. The 0 power. And that's going to be equal to our 1. All right, the next one, log base 2. So there's our 2. That's our base. To the what power? The 9th power, because that's what's on the other side of the equal sign, is equal to what? 512. Yep, you got it. All right, so then here we go. You do this next one. Log base 6. 6 squared is equal to what? Yep, you got it. 36. Okay. So here's a few more examples and you tries. So we're going to go back and forth between these, okay? So, and these are written in different ways. So we're going to take our 49 to the 1/2 power, and that's going to be equal to 7. You go ahead and try the next one. Okay, 64 to the 1/3 power is equal to 4. The next one, 5 to the -3 power. Remember, if it's negative, it's going to the denominator. That's why it's 1 over 125. Okay, then we got our base here again. 2 to the -5 is equal to 1 over 32. Here's our base. 1/2 to the -3 is equal to 8. Now, the reason that is because when we take a fraction to a negative power, it's going to flip, right? So it's really going to be 2 to the 3rd. And 2 times 2 is 4 times another 2 is 8. Okay, so our next one down here, we're going to do 1/3 to the -2. Similar concept, right? Because it's taken to a negative power, it's going to flip. So it's going to be 3 squared, which is 9.